All the time on this channel, we're talking low airflow issues, coils freezing up, and all sorts of stuff like that. But what about high airflow? What is the problem with high airflow? That's more sensible cooling, right? The more airflow you can put across that coil. But there's issues with that, just like there's issues with low airflow.
The new Yellow Jacket scale, part number 68864, has a 220-pound capacity, a large platform, and wireless Bluetooth communication via the WideJack app. With a 0.05% accuracy and 0.2 ounce resolution, service technicians can count on precision measurements every time.
Let's imagine for a minute we have a coil that's 3 tons that's designed for 1100 CFM to move across it. Just as an arbitrary, we're going to grab a number. The nominal CFM for a 3 ton is 400 per ton at 1200, but a lot of times they run a little bit lower, and there's a reason for that. In fact, a lot of times whenever systems are evaluated for efficiency, they run at a higher CFM than you actually would run them installed at somebody's house, because the higher that airflow goes, the higher that coil temperature will go, and there's a problem with having a higher coil temperature. The higher the coil temperature is, the less likely you're going to get the proper amount of dehumidification, because there's kind of a give and take on an air conditioner coil between sensible cooling and latent cooling. You can change the balance of sensible to latent cooling by changing the CFM of a system. If a coil gets colder, the colder it gets, the more it'll dehumidify to a certain point, but you'll have less total cooling, because as you decrease CFM, you can only offer a certain amount of sensible cooling to the structure. So there's always a give and take, and you have to analyze what CFM you're at. The reason why I'm talking about this is when you have a matchup of different systems and you have to fine tune them at the installation process, a lot of times guys will overlook CFM altogether. They'll fire it up. If the pressures look relatively good, you'll say, perfect, you'll let it go. We don't do a whole lot of testing out there, especially it's summertime, everybody's under the gun, everything seems to be working. We'll come back and check it later, and of course later never comes. It's like 5 years later whenever you have to service it for some reason. But if you have excessive CFM, they might reach the temperature on their thermostat. Let's say they set their thermostat at 75, which is a relatively high number these days is what I found. It gets to 75, but because that CFM is higher than it should be, there's not enough latent cooling, so the room still feels sticky and humid. They have to run it down to 72 and maybe to 70, and the unit ends up being less efficient because they had to run it down lower, and maybe their bill's even higher than before the unit was installed, and then you get some complaints at your company because you thought it was a 16 or 18 SEER and now it's costing more. Why is this happening? That fine-tuning at the installation process makes a big, big difference. Fine-tuning the CFM, testing it, or going through the proper process on a variable speed or communicating system to ensure you have the correct CFM is paramount. It can change how people feel in their homes dramatically. I know when my home is more humid, it just feels uncomfortable. Even though the thermostat may say 70 degrees, if it's humid inside, it's uncomfortable. I run a fan. But if dehumidification has taken place and our humidity is down, let's say at 45 or 50%, and it's 73 or 74, it feels more comfortable than it did at 70 degrees at like a 65% humidity. It's just it feels clammy and disgusting whenever you have a humid house. So you should avoid that. And you avoid a few things by doing that. You avoid somebody calling back shortly after. You avoid just a constant, because people don't like to call and complain about stuff. Some people do, some people don't. A lot of people don't. But those people who don't will just have that system and dislike it and associate you with that dislike. And you don't want that. That's the silent thing you don't get to see if you do a bad job. And we'll say an incomplete job. I hate to say a bad job because it's not the right word for it. But if it's an incomplete job and people have to deal with this day in and day out, they don't make that phone call, but they also never call you back again because they said that system you put in, it feels worse than the old one. So do it right the first time, and you can avoid some confrontations and some just loss of business that you never even knew about. But I hope that helps everybody. Testing is important. Testing CFM is very important, and it's underdone in the industry as far as I could tell. My name is Zach Scioto with HVAC Shop Talk. I hope I see you guys on the next one, and God bless all of you.
Save 8% off your order at TruTechTools.com by using the Shop Talk discount code.